All right, so now that we know how to name a hydrate, let's determine how we find the chemical formula for a hydrate. Okay, so first off, we want to start by reading the problem and seeing what we have. So in this case, the problem, we're told that we have a mass of a blue anhydrous copper sulfate, or hydrous copper sulfate, and then we have a mass for our white anhydrous copper sulfate. So we have two things we're going to be looking for. We're looking for that mass of the hydrate and the mass of the anhydrous. And this is going to tell us how much water is lost. So first off, before we do anything else, let's figure out how much water is lost. So we take our 2.5 grams, because that's our hydrate. So this is our copper sulfate, CuSO4. And it is an XH2O. We don't know what X is yet. We're trying to figure that out. And we're going to subtract that from our 1.59 grams of our white anhydrous. Now, the white anhydrous doesn't have any water attached to it. It's just copper sulfate at this point. Once we find that difference, here we have 0.91 grams. Well, what is this grams of? Well, if we have copper sulfate here and we have a hydrate of copper sulfate here, the 1.9 tells us that this is the amount of water that was lost. So that's actually your H2O right there. So once we have that, then we need to convert our grams of water to moles and our grams of our compound to moles. So here's what we do know. We have 0.91 grams of H2O. Let's convert that into moles. Remember, you put the molar mass of water down here, which is 18 grams, over 1 mole. Divide by, or multiply the top, divide it by the bottom. You get 0.05 grams of H2O. The copper sulfate would be the anhydrous because that's just your compound. Okay, so we have 1.59 grams of your CuSO4. The molar mass to that is 159.6 grams of CuSO4, 1 mole. Multiply the top, divide it by the bottom. We find out that we have 0.00996 moles of copper sulfate. Okay, so now we're going to solve for X. So X would be, as we said up here, our number that would go in front of our water molecule to determine what type of hydrate we have. So we have a little formula for that. X is equal to the moles of your water over the moles of your compound. CMPD is the abbreviation for compound, by the way. So in this case, here's our moles of water. Here's our moles of our compound. So we're going to put our moles of water 0.05 grams of moles. Put the wrong label here too. Should be moles. Moles of water. Go here. And we're going to put that over our moles of our compound. So 0.00996 moles of copper sulfate. Okay, we divide that out and we get 5. If you have 5.002, it's still 5. So we're going to go with that. So here's how we're going to write this. So we write the compound CuSO4, 5, because this becomes the X that we are looking for at the beginning, H2O. So we're going to name this. So it's copper 2 sulfate. You're just naming the ionic compound there. 5 would be pentahydrate. All right, so let's do one more of those. So in this case, we're going to use barium chloride. This is a hydrate here. And we have an anhydrous compound of 4.26. So it's asking us, we got a hydrate and we got our anhydrous. So the two things we need. So step 1, we subtract the hydrate from the anhydrous. So you have 5.0 grams minus 4.26 grams. Now this is your hydrate. So we need to know, and this would be your barium chloride, BaCl2. So in this case, we're looking for our BaCl2 X H2O. We don't know how many water molecules we have. So we find out our water. And water in this case, when you solve, is 0.74 grams of H2O. So then our next step is converting our grams into moles. Okay, so let's start with water. 0.74 grams of H2O. And we are going to put 18 grams, because that's the molar mass of water. 1 mole H2O up here. Divide the top, or multiply the top divided by the bottom. You're going to get 0.041, I believe, or 0.4 moles of water. Then we do barium. Now this would be our anhydrous, and so we know from the problem we had 4.26 grams of our anhydrous, so that's just barium chloride. We have 1 mole barium chloride on top. Find the molar mass of barium chloride is 208. Again, we're using the periodic table to find the molar mass for that. Multiply the top, divided by the bottom, you get 0.02 moles of your barium chloride. Now, with your barium chloride, we're going to solve for X now because we're trying to figure out what that hydrate is. So again, this is moles of H2O over your moles of your compound. If you want to write this little equation on your periodic table, feel free. So in this case, we have 0.04 moles of H2O over 0.02 moles of barium chloride, and you get a number of 2. There's no label for this, by the way, because you're going to put it into the equation. So when we write this chemical compound out, we need to make sure we know this number, because now this is going to be our X. And so we have BaCl2, because that's what our compound is, 2H2O. And if we write that name out, it's barium chloride 2 dihydrate. And so that's how we name those, and that's how we solve for these. All right, have a good day.